discuss the third homework. So please, what we will discuss? Tell me.
Couple seconds.
All? Okay, let's start from number 2. If we have time, we'll continue. Maybe something more?
Yeah, but do you need A and B in number 2? The whole one?
Yeah, I
Right.
think the whole one.
Right.
Whole one. Okay? Okay, let's start. Oi. So we will speak about labor-leisure choice. Yes? So first of all, what we have? Time endowment T. Then utility function that depends on the consumption and leisure is presented by Cobb-Douglas function CL, yes, leisure. And if this agent is unemployed, then he gets an unemployment benefit beta. Okay, so now point A. Derive the labor supply curve, illustrate it, and explain this law. So we should present analytical solution, graphical solution, yes, and explain intuitive one. Point A, labor supply. So this is the decision how much to work for each wage. Yes. So how we solve this problem by utility maximization program. Yes, we write down the utility maximization program. Subject to budget constraint. So budget constraint, if we work, it is how to write down.
C plus WF equals WT.
Yes, exactly. So here, if we speak about interior solution, but first of all, we need to prove that we will speak about interior solution. So if consumption equals to 0 or leisure equals to zero, then our utility level is 0. Yes, but we can improve this situation. Yes, we can increase the utility level. When, for example, spend part of time on leisure and part of time on labor, yes, and consumption. When divide time on leisure and consumption. So, okay, that means that we will not have corner solutions. It is not optimal for us, yes, because we can increase our utility. So no corner solutions. And that's why we can provide the solution for interior case. Easy marginal rate of substitution is what? Consumption to leisure, or leisure to consumption. How we will write down leisure to consumption is what?
C divided by N.
C divided by leisure, yes, and it should be equal to the price ratio. Price ratio is our wage, yes? Wage subject to our budget constraint, so I can rewrite it C equals to wage multiplied by time minus leisure. Okay, And we should solve this problem. From here, assumption is wage leisure and put into budget constraint. Here will be wage leisure equals to wage time minus leisure. And from here we got that we'll spend half of time on leisure, yes, and that means that we will spend half of time on working, yes. But because we're solving utility maximization program, we should write down the optimal consumption also, because the solution consists of two things, yes, consumption and leisure. So consumption will be wage multiplied by leisure, so this is wage multiplied by time over 2. Okay, so that's the first part of labor supply. Now what we should find? Reservation wage, exactly, yes. So now let's find reservation wage. Under such wage, we're indifferent to work or not. Yes, so our utility will be the same. Yes, utility level. So the utility level, if we work, it is square root out of C multiplied by leisure. Yes, square root out of WT over 2 multiplied by leisure T over 2. So this is square root out of wage multiplied by T over 2. And if we don't work, it is what? We will get the unemployment benefit, yes? We will get the unemployment benefit and we will spend all the time for leisure, yes? And we can consume only for such money, for unemployment benefit, agree? So here will be square root out of consumption beta, and here leisure T over 2. Okay, so, and they should be equal to each other, yes? So let's find this reservation wage. So square root out of wage T over 2 equals to square root out of beta T over 2. So here we can delete, and here will be square root, yes? So wage, this reservation wage will be equal to 2 beta over time. Is it correct? Like this? Did you have such answer in your homework about reservation wage?
May I quickly ask you a question?
Uh-huh.
Why do we not take into account that beta in our...
Over 4. Sorry. Over 4. Uh-huh.
Why do we not take into account beta in our constraint in the beginning of the utility maximization problem? So our constraint looks like there is no unemployment benefit, since we receive only with working all hours, the right hand side of our.
Yes, because we will get an employment benefit if only if labor will be equal to 0. And here we consider interior solution. Let's say that interior solution, that's the situation when we work. It is bigger than 0, less time, like this. Yes, it's interior solution. Okay, here, then we solve for over 4t. Yes. Let me check one more time. No, 4 beta over t it should be. Where is the mistake? Let me do it one more time. And let's say that we will work if our utility is greater or equal, yes? When we work, greater or equal than utility when we not work. So we can do it without square roots, yes? Root t squared. 4 should be greater or equal than beta t over 2. So we can delete t here, we delete here. Here we have 2. Should be greater or equal than 2 beta over t. Why 2 beta? Beta. Why? If we will not work, we will spend all time here. Here there is no divided by 2. Yes. If we will not work, our consumption will be equal to our unemployment benefits, and leisure will be equal to overtime. So here without 2. Yes, so now I found the mistake. So here without 2. Here 4. Here 4. Okay, great. So now we are ready to write down the labor supply. So reservation wage for beta over t, and labor supply equal to t over 2. If reservation wage, if our wage is greater or equal than reservation wage, it is 4 beta over time, and we will not work otherwise. Yes, wage less than 4 beta over time. And you see that our labor supply does not depend on wage. Yes, it's absolutely inelastic. You see. So we should present the graph. So let's do it. It's easy. So in vertical axis, name them here wage, here labor. Yes, we should present labor supply, so we will use this axis. Agree? Then, and we have 2 parts. It will be equal to 0 if wage less than reservation wage. So put this reservation wage somewhere here. It's 4 beta over time.
So it will be like a vertical line from the 4 beta by 3t.
Yes, exactly. So here t over 2, it's constant. Yes, it doesn't depend on wage. And here we include point because here greater or equal. Yes, so this is our labor supply. So guys, please ask.
No questions. No words.
Okay. Then, what we have? Explanation of the slope. What we can say?
The amount of wage doesn't affect on time work if the wage is equal to 4 beta divided by 2.
That's the one thing. Do you remember that if our quantity supplied, yes, of labor increases with the increase of wage, in this situation, substitution effect is greater than income effect. We have 2 effects. Yes, substitution effect when the wage increases, that means that leisure becomes more expensive, and we increase our labor hours. Yes, we substitute more expensive food. Then, income effect, what tells us that when wage increases, yes, our real income increases. That's why we can consume more leisure and consumption at the same time if leisure is normal. Agree? So, at one point, leisure should decrease and labor increase. On the other hand, vice versa, labor should decrease, yes, and leisure should increase according to income effect. And here, it is not increasing nor decreasing. That means what that means?
Why is it better?
This we are trying to explain now. So, in such situation, if substitution effect, yes, by module is bigger, yes, than income effect, then vice versa. Such situation is vice versa when income effect now is bigger than substitution effect. In such situation, they are equal to each other, yes? So, this is the explanation. So, explanation is because they balance each other, yes? These two equals to substitution effect. Good? So, okay, let's move on.
Do we always assume that price equal to 1? Just price of consumption, or
Yeah, it's written in the task, I think. But you can use price as constant. It will not change anything, as you know. Okay, so here they're equal to each other. So total effect is 0. They balance each other. Good. Then in point B, there is an increase in unemployment benefits. Yes, and we should show graphically how the reservation wage will change. So, point B. No, unemployment it decreases. Yes, unemployment benefit decreases, and we should illustrate how reservation wage is affected by an increase in what will happen to reservation wage. From such graph we can see that reservation wage will decrease. Yes, but here we should provide another graph. In which axis?
Consumption.
Yes, it's leisure consumption. Our two goods. Yes. So put here time constraint. Put time. Then what else we can draw? Okay, let's draw this point. If we doesn't work, if we do not work, what that means? This point with t and beta is affordable for us. Yes, let's put this point somewhere. So this point is affordable if labor is equal to 0. Yes, and what we also know? We also know if labor is a little bit greater than 0. We will not have this unemployment benefit. Yes, agree? That means that we will not have this endowment. Yes, in monetary terms. So we will have only our standard budget constraint, but without endowment. Yes, and the slope is our wage. And let us show this situation with reservation wage. We know that we're indifferent between work and choosing not to work, yes, when we have the reservation wage. Agree? So we've made it here. We equalize them. Yes, these two. So this wage, this slope, will be equal to reservation wage if our choice to work, we know how much it will be t over 2. Yes? Right. They're equal to each other. These two parts. And these 2 points should belong to the same indifference curve. Yes? Let's use another color. Oba. This with beta 0. This reservation which 0. So one more time. We are indifferent to work or not to work. Yes. So in this point, labor is equal to 0. In this point, leisure and labor are equal to t over 2. In this point, labor is equal to t over 2. Good. And now our unemployment benefits decreases. Yes? So this point will be lower. Yes? So let's do it. That's right. So now it's somewhere here, beta 1. Yes. Total amount of time is the same, but now what we will have? Yes, way flatter, because our choice how much to work will not change, t over 2. So we will choose point somewhere here, yes, and it will be flat. So let's do it. Observation reach 1. You see it's the slope is lower, yes? And let's see 1. What else? It shouldn't be only here, it can be up there, okay? So now we show that reservation wage will decrease if unemployment benefit is lower. What else? Labor will stay the same, it's inelastic. I think that's all about point B.
So the explanation can be that because of the decrease in the unemployment benefit, people want to work more, and that's why there's a lot of supply of workers, so the wage falls. Like the intuition behind that.
Intuition, because our unemployment benefits decreases. That means, but here our labor supply will stay the same. Yes. That's why we are ready to begin to work for lower wages. Yes. Now we are ready to work for lower wages because we will gain less if we will not work. That's all. Good. What else? This was point B. Then point C. Let's do point C. Here, now we will not have unemployment benefits, but this beta will be our non-labor income, standard case. And we should compare these labor supplies. It's here will be a beautiful graph. So now beta is non-labor income. And we should find labor supply one more time. Then we should present it on the graph and explain its difference in its slope position in a comparison with previous labor supply. So what we know? Let's find the interior solution. First of all, as always, we should write down the utility maximization program one more time, but let's skip it. We know that we should write down it. Yes. For interior solution, as always, marginal rates of substitution should be equal to price ratio. We know our marginal rate of substitution. It is leisure to consumption. So this will be consumption over leisure. Yes, like this, and this is our wage. Subject to our budget constraint. Our budget constraint changes. We now have non-labor income. So consumption plus wage multiplied by leisure equals to our time that we multiply by wage plus non-labor income plus beta. And we should solve it. Let's do it. From here I will say that consumption equals to wage multiplied by leisure, put it into budget constraint. Here will be 2 wage multiplied by leisure equals to wage time plus beta. So leisure, this is a system. Then leisure equals to T over 2 S plus beta over 2 wage. Am I right? Check, please. And but we should find what? We should find labor. But first of all, consumption is wage multiplied by labor. Wage multiplied by leisure. This is 2 over 2 plus beta over 2 wage. And part of labor supply is time minus leisure. That's fine. Time minus time over 2 minus beta over 2 wages. And this is time over 2 minus beta over 2 wages. So let us check the law of supply. What we can have. When substitution effect is greater than income effect, we will have standard. Yes, so the higher the wage, the more hours we want to work. Yes, let's check. The higher the wage, the lower this part, and we subtract lower number. Yes, so labor supply increases, quantity supplied increases, so it's okay. What else? We should find our reservation wage one more time. Good? Let's do it. But before, let's check that this is exactly interior solution. So labor should be greater than 0. Yes, for being interior solution. Let's check it. this should be greater than 0. When it will be like this, for what, for which wages? T over 2 minus beta over 2 wages should be greater than 0. This is T to the right, T over greater than beta over t. Okay. We will use it. And it's also less than total time. It's okay. It holds. So this is the solution. Then let's find reservation wage. What we know? We know that this is the situation, our standard situation. Yes, when our indifference curve, yes, has tangent point exactly in the point when we do not work. Yes, do you remember this? This tangent point, and this is our standard budget constraint, like this. So this is the reservation wage. Yes. Okay. So in this point, where it's optimal for us not to work. That's the last point. Optimal for us not to work. That means that marginal rate of substitution of leisure by consumption in this actual point. When we do not work, okay, leisure will be equal to our time. We will spend all time lying on the sofa. So, and how much we can consume?
All the money that we have.
Yes, and we have only non-labor income. Yes, because we do not work. Only non-labor income. It is beta right now. Yes, and it should be equal to the slope of the budget line, so to the reservation wage. Agree? So easier. Yes, remember that marginal rate of substitution, it is here consumption over leisure. So our consumption is beta. Our leisure is we spend all the time, and it is equal to the reservation wage. Let's check. Yes, we found the same. See? It's the same. Good. And now we are ready to write down the new labor supply, and we can compare it with the previous one. New labor supply will be equal to T over 2 minus beta over 2 wage. This is true if for wages greater or equal than our reservation wage, so beta over time. And we will not work, otherwise, yes, if wages less than our reservation wage. And the most beautiful part is comparison. Labor, wage, but also. So you see, before the reservation wage was bigger, yes, for beta over t, and now it is lower for beta over t. Yes, it's an interesting point. So here was for beta over t, and now it is beta over t. And first of all, let's draw the previous one. Previous supply, please, it's easier. Yes. T over 2. You can use your previous graph. point A. And what's now? Now, what we have? We will not work lower wages than new reservation wage. This part, but then what is how this labor supply will look like? What we see that the higher the wage, the lower this part, yes, and our labor supply can become closer to T over 2. Yes, you see? So the higher the wage, the lower will be this part, and that means that our labor supply will be closer to T over 2. Yes? So how we name this T over 2 from math? Asymptote. Okay. So it will be it becomes closer, yes, but it will never be equal or more. Yes, than before. This is new labor supply. Labor supply from point C. Now we should explain why with the unemployment benefit we have such a strong change. Yes, and here we have like a smooth change. Yes, because you see in our point C, beta is our non-labor income, and we have it when we work or when we don't work in any situation. Yes, and that's why when the wage a little bit increases, we will increase our labor supply for a little bit, because before we had this non-labor income, and now we has also the same non-labor income. But in point A, if we begin to work, we will not have this unemployment benefit. Yes, it will disappear. Yes, and for example, let's decrease the wage. When wage decreases a little bit, we will have now this unemployment benefit, and that's why we switch from half of time working to not to work, because our income will not increase, but we will have other income, this unemployment benefit. Yes? So, what else we can explain? So I think I will not write down it because I explained it in words, but so guys, please ask. Did you partly?
Yes.
What was the hardest part?
The reservation wage.
Reservation wage. So you can use this thing that according to when we have reservation wage, we're indifferent to work or not to work. You can equalize these utilities, levels of utility. Yes, and from this, I think it's easier than doing with marginal rate of substitution. Yes, more intuitive is to equalize utility levels. Yes. Okay, now we have let us proceed to uncertainty. We have only one. We have only one task, but anyway, I hope we will finish it. fast. Who will come to the point A? Because it's easy one. Point A. Please. Yes. So first of all, let's write down the task. So try to write yes by yourself, and then we will discuss. Okay? Can you please write down the task and try to write down also some thoughts about how to solve it. Use your lecture notes. When I was solving it, I opened lecture notes and it was in the lecture. What's this? UI.
I mean,
Expected.
yeah.
You want you want to write average to something like that. Expected.
Like this?
Yeah, you. I don't know.
Ah,
Expected. Who found this maximum fee? remember that we cannot use calculators. Yes. It's easy to count. Okay.
As you remember, we can put it as a term. So like for
Я все вижу. Okay, this is square root of not square root of power 3 out of 27. 3, yes. Then 64 square root out of 64. Easy. А 3 раза что надо умножить? 4. 4 в квадрате. Too difficult calculations. Very good. So this is the maximum. So let's discuss one more time what we have. We have two options. Yes, to work in startup or to go to work in the firm A. Yes, and to work in startup it's risky. Yes, because our compensation depends on the probability of startup success. Agree? Yes. So with probability 2/3, we will have our fixed this part of compensation plus 37 because our startup is successful. In the other situation, if it is not successful, we will get only our fixed compensation plus 0 without any other part. Okay, and our expected utility from working in startup. Yes, we should present it by using this elementary utility function. Yes, so this state of the world will have, and we will get such level of utility with probability 2/3, and such level of utility we will get with probability 1/3, and this is expected utility. Good? Then, if we will go to work in the firm A, our compensation will be fixed 50, but we should pay this fee to leave the startup. Yes, it's like compensation to startup that we go to the other company. Yes, okay. So, but there is no risk. You see, we will get this 50 with probability 1. So, and we are ready to switch to work in company A only if the utility from working in company A is greater or equal than expected utility from working in startup. Yes? So if we say that here is greater or equal, you see what? So for such fees, we are ready to leave the startup. And when we will write, so for each fee that is less or equal than 4, we are ready to switch to firm A. Ready to go to firm A. And you see that our logarithm, it is monotonically increasing function, and the higher the p, the lower this value. Yes, and the maximal phi is exactly when here is equality. Yes. Equality is for f maximal, and we found it. It's 4. Good. Okay. Then now we should show all this by using the graph. Our favorite part. Let's do it. Who wants to draw a graph? Who wants to try? No. In B, we should compare this maximal phi with the change in compensation. Who can calculate the change in compensation? Do you want? Please. So this is not utility but value, yes? It's in money terms. Yes. So it is 1/3, and now we should compare it with this maximal phi. It's less, yes, than maximal phi. So we need to explain why. What that means? It means if we switch from our startup to the firm A, our expected our expected compensation will increase by only 1/3. Yes, but we're ready to pay more than 1/3. Yes, to go to the other company. Why it is so?
It's to avoid risk.
Sure. Yes, because our guy is our girl Helen is. How we name such person? Risk.
Lover. Risk lover. I think.
I think no, it's
Risk.
risk averse.
Risk averse. Yes. Risk lover will want to pay less than 1/3. It will be ready to pay less than 1/3. Yes, or will not pay anything. Yes, but risk averse person, she is ready to give up more. Yes, than 1/3 to avoid the risk. Agree?
Yep.
So to switch to a risky project. What else we can say? If, for example, if this expected change in value will be 0, for example, if it is 0 and f is our maximal value we are willing to pay, how we can name this value? Remember, to avoid the risk. If expected value stays the same but without risk, and we are ready to pay this, how we name it?
Risk premium.
Yes, it is risk premium and it is bigger than 0. And now, because we have here this change, in this f, risk premium is included and this change in our value, expected compensation. Yes, it's together included. Okay, good. Could you draw the graph?
Yeah, I'll try.
Okay, let's try. So prepare a not small graph, okay?
I have a question. So this should be the maximum amount of the.
You want to start from LM2, yes? Okay, like this.
Or you don't.
We can do like this, it's okay. So here will be how much?
The minimum 25.
25. Yes, here 25, here this. And on your x, this will be x.
Yeah, this is you, right?
This is you, yeah. I don't write. Now, how we will you want to start here from 2, yes?
Yes.
Yes. And so here will be not 0 but x.
Ah.
If we use this part. Okay.
So we can start like from the 0 and from the 2.
We can start from 0 because this is like this value. Yes. And here value in the other state of the world, or we can draw in terms of x. Yes, and x is 2 plus.
So here actually the intercept.
What is our task here? We should use Let's read the task one more time. What we should use. Mhm. Mhm. Repeat part B using wealth utility diagram. Wealth utility. So I think it's better for us to, if it is wealth, it will be this, and wealth it is x plus 2. Because we need to write wealth utility diagram here. Yes, so we will start from 0. Okay? But our conclusions will be the same, exactly the same. But let's stick to the task. Uh-huh. So it's
yeah.
plus 2.
Why did we decide to start from 0 if
Our
it's
task
possible?
is to present the graph in wealth utility diagram, and for our agent, wealth consists of 2 plus this compensation. Wealth is not only the compensation. Yes, because this is elementary utility function. Here is wealth in such state of the world. Okay? Mhm.
Why not we have interception in point 2 on utility axis? Because we cannot have negative compensation x since our minimum utility is 2. We are not going to go through the origin. You understand, right? It's like
One more time. So this is our utility function, and we can rewrite it as the utility from our wealth in the state of the world, and this will be natural logarithm from wealth. It comes from 1. Yes? Let's do like this. Better? Let's agree things. Можно удлиться как 25. Ну да, но только требуется написано E от V2 это без вычитания. Потому что E это V, разница делается. E от V это, вот так еще плюс 2. V у нас change, да, но нам надо же еще поставить все эти точки. До change еще далеко. Yes, this is the risk premium, and also we should point our firm A choice. So if we will not pay this fee, we will earn our wealth will be how much?
1148.
Yes, from 52. From 52. Yes. F equals to 0. So this will be 50.
If F0, why not F4?
We will start from this situation and then we will write when f is equal to 4, the last situation for which, okay, if f is equal to 0, here 52, yes? Uh-huh. So put somewhere here 52, because this difference should be 1/3. Yes? Expected plus 1/3, it is 52, agree? So, and we should point the utility from our wells 52. Please show it. So we will earn it without any risk, yes. So we put this 52 into our utility function. And we'll get this one. Uh-huh.
So here's 52.
Uh-huh. Yes. And this if f is equal to 0. Yes, this if f equals to 0. How we found this situation with maximal willingness to pay? What we equalize? How we found this maximal fee?
Equalize expected staying in the top.
Expected utility from A should be equal to expected utility from startup. Mm-hmm. Where is the expected utility from startup?
0.
Mm-hmm. This one.
So we should make this one equal to utility
This is the utility from 52 minus f maximal. Agree? We equalize them. So this is 52 minus f maximal. Yes, certainty equivalent for which we agree. This is 52 minus f maximal. Uh-huh. So, and could you show this maximal f? The difference. Maximal f, this difference. So you showed risk premium and as the same, show please maximal fee.
Please explain one more time. How do we set the point 52 on the horizontal axis? Why do we put it in this area, like in between, especially in between EV and 64? Why do we put?
Not from 64, it is 52.
Yeah, I mean, why do we put it especially here? Like,
Why we put 52 to the right from expected value?
yes, but to the right for this some 1/3 distance or some.
Is the change in expected value is 1/3. Yes, in startup, in the new.
Yeah.
Yes, in the new situation it is 50. In the startup situation it is exactly expected value because it's our lottery. Yes, and the difference is 1/3 because that means that without this fee, when we with this fee, okay, if we move to the firm A, we will gain, yes, on average 1/3.
Yeah, is it in B part of the task when we compare expected changes in wages? Yeah.
This is uh-huh. And what we see right now, we see the last slide. This is maximal F, this is risk premium, and this is the change in wells.
Yeah.
Yes, so our maximal fee consists of the change in wells plus what we want to pay to avoid the risk.
So every time it has 1/3 change.
It's only expected change in money. it's 1/3 because these are our earnings in different states of the world. Yes? Uh-huh. Do you got it?
Yes.
So very good. Thank you so much. But, so ask, guys, what to repeat? Good?
Yes, yes.
Okay. So, okay, see you. Thank you. Thank you so much.
Давай. Удачи тебе, работь своей. Держим кулачки.
До свидания.
Можно last question? Скажите, пожалуйста, может, что делать? Я читаю всю литературу, даже семинары главных фильмов, но все равно очень тяжеловато курс идет. Вот, может быть, вы посоветуете, не знаю, какую-нибудь дополнительную литературу читать, потому что я этого Берлова и Снайдера уже, не знаю, затираю.